here we're trying to find the particular solution for a differential equation. And we know that the curve passes through a given point, so that will allow us to do that. So the first thing we do is write out cosecant the way we are familiar with, then multiply both sides by dx. We do that so that we have the dx with the x on the same side of the equal sign and the dy with the y. So I'm also going to divide both sides by y so that I have the y on the same side as the dy. So what I'm trying to do is separate the variables. So it's called separation of variables. So it's called a separable differential equation. So I'm going to divide both sides by y, so I'll have 1 over y dy equals minus 1 over cosecant x dx. Now cosecant x, that's just 1 over sine x. So I have the reciprocal of cosecant, so 1 over cosecant, so that will be the reciprocal of 1 over sine x. So if I write it out, cosecant is 1 over sine, then 1 over cosecant is just 1 over sine. Well, it's just sine, so it's the reciprocal of 1 over sine. That's good news because it allows me to integrate sine x. And I know how to do that, whereas I don't know how to integrate cosecant. Okay, so now we're almost there. Now we just need to integrate both sides. So if I put in an integration sign on the left because I've got y and dy, and on the right because I've got x and dx, the integral of 1 over y is simply the natural logarithm ln y, or the absolute value of y. The integral of sine is negative cosine, and I have two minus signs, so let's just combine those into one. So now I have what we call the general solution. This is called the general solution. But we don't know the value of the constant c, but we can find it because we know that the curve passes through a point pi e. So by substituting pi and e into x and y, I'm able now to calculate the value of c. And if I know the value of c, my general solution becomes a particular solution. So I'm going to replace y with e, so ln e is cosine pi plus c. Now, cosine pi is -1, provided, of course, you're working in radians. Now, when you're using integration or in all calculus, you should always be working in radians. So make sure your calculator is set in radians if you need a calculator for cosine pi. Otherwise, your calculator will give you misleading results. So now we know that, and ln e is 1, so now we could just write 1 is equal to -1 plus c. And I can rearrange that to find c. So c is 1 plus 1 is 2, and I can substitute that back in my general equation or general solution, and that will give me my particular solution. So my general solution has a c in it. My particular solution shouldn't have a c in it. It should just have x and y. So that now is my particular solution. That's what they ask for in the question. That would generally be acceptable. Although you might want to simplify it further to make y the subject of the formula, i.e. to take exponentials of both sides or apply the definition of ln. So you have y is equal to e to the power of everything on the right-hand side. And that might be a more acceptable form of the particular solution. So particular solution, where possible, you want y equals rather than ln y equals or cosine y equals. But both of them are correct in the sense that they are both true statements that express the particular solution. So that's how you would find the particular solution of a differential equation using trig.